Hi, everyone. As you may know, on my channel, I cover Python tutorials with a focus on data analysis, with a special emphasis on, I should say, scientific image analysis, primarily microscopy. But of course, the approach is very similar whether you're doing medical imaging or remote sensing, satellite, and drone imaging, and so on. So this is the primary focus. And bulk of, oh, by the way, if you haven't subscribed to this channel, this would be a great time to actually pause the video and hit that subscribe button underneath. And if you're feeling extra generous, try to find the thanks button and, of course, enable notifications so you get notified when new content is available. Okay, with that thing out of the way, let me jump into the main topic here. The focus of this specific tutorial is not to write code from scratch like we normally do, but to actually see if chat engines can be used to accelerate your coding experience. But I should say, if you really want to accelerate your coding by leveraging the best work that others have done, then look for some of the open source libraries. For example, in microscopy image analysis, there are a lot of amazing groups that actually have published good, excellent libraries for most tasks, like whether it is segmentation, denoising, whatever classification. You'll probably find good libraries out there, and that is one way of actually accelerating your journey from image to insights. Now, if you don't want to code, if you are new to coding relatively, but then you know a little bit of coding, you know how to handle and how to debug if the code doesn't work, then chat engines can be a good way of actually generating bulk of the code. So you get 90% of the code done, and the remaining 10%, you still have to manipulate things. That's why if you're a biologist or any other researcher engineer with skills in the domain, like a strong domain knowledge, then you can definitely leverage these chat engines to actually generate the code and take that and then kind of adjust it a little bit to your specific need. But if you are trying to just generate code, copy and paste, and expect it to work, I am afraid that's not the case as of today, which we will learn. Again, I'm going to do this exercise for the next probably 30 minutes, 40 minutes or so, but I gave you the insights right in the beginning for those of you with no patience to watch these type of long videos. Okay, with all that, let's actually jump in. And again, this a special mention, like obviously today is 28th. I'm looking at my date right there, 28th of July. It's a Sunday where 2024, I think that's more important than the date itself. Why am I telling you that? Because it gives you an idea of the type of models I'm working with. Maybe you're watching this video 1-2 years from now, and some of the insights we gain here are probably not relevant anymore. This is such a rapidly changing field, right? Okay, so as of now, I'm especially excited about the recent Meta Llama 3.1 with 405 billion parameters, I believe. They call the model 405B. So this is something that I plan on actually trying out to see if that actually does a good job in terms of generating code that's usable right out of the box. And of course, when it comes to ChatGPT, GPT-4o is what we're going to use. And for Claude, my favorite engine is Claude, actually, for language generation, not for coding. And I believe it's using Sonnet 3.5. We'll see that once we get into these, the browsers. Okay, with that information, let's go ahead and define the problem first, and then actually get into each of these chat engines and then see how they perform. Okay, so what you see on the screen is my Spider IDE. We'll get to that later, in terms of copying and pasting code, but that's what I plan on using. But for now, let's have a look at the image that we will be using. So this is a multi-channel image, as you can see, the blue color with all the nuclei, and some of these nuclei are obviously very close by, so we need to separate them from a segmentation point of view, as you can see over there. Let's move. Yeah. So, and now when I turn the red channel on, I believe these are all mitochondria around the nuclei. And the green channel is the cytoplasmic region. So this is it, a simple scientific image with 3 channels and 3 different types of information. And our goal is to segment the nuclei. Okay, and get the intensities. So I'm using 3.5 Sonnet for Claude, and let's jump into ChatGPT. So this is 4.0 and Copilot. I don't know what Copilot uses. I tried to find that, but it's tough to find some information there. We'll get to Meta AI, and also Gemini is another one that we'll try. So let's start with Claude, and let me define the problem here. So you're a biologist with microscopy and Python coding skills. I'm telling the chat engine what it is. Now, you're tasked with writing Python code that loads a microscopy image, .czi image with 3 channels. We just saw the 3 channels. Your goal is to segment individual nuclei using the 3rd channel, which is the DAPI channel, right, the nuclei, and measure the mean intensity of first 2 channels and ratio them for each nucleus. Okay? And finally, go down, plot the segmented nuclei image and save the mean intensities and give me a CSV file. So that's the task there. And of course, I'm telling it that note that the goal involves segmenting individual nucleus so it can separate them using Watershed or whatever it likes to use. Write the code for the above task and appropriate comments for the code. So let's go ahead and run this in Claude, and while it's running, let's go ahead and copy and paste it in ChatGPT. Let's do this, and let's go ahead and run this. This may obviously takes a few seconds for it to compose, and let's go to Copilot to do exactly the same. I'm leaving this in the balanced, creativity mode for it. So let's go ahead and do that. And next comes the Meta AI, and here, since this is new, 405B Llama, we have to go, at least for now, change the model from default 70B to 405B. This is the latest model that I'm excited about, so let's go ahead and use that. And let me get back and paste, and let's go ahead and hit enter. So, okay, so while that's running, let's go and do the same with Gemini. Okay, so there you go. Fine. So it's generating. Let's get back to our Claude, and yeah, everything is done. Let's scroll up, and I'll give all the code to you, whatever it generated, so don't worry if the screen is small. Okay, so it's using something called AICS PyLibCZI to open the CZI file, but it's doing the good job of actually assigning the 3rd channel to DAPI and all that. But this library, I don't think it can open my CZI file, but that's okay. Let's see. And it's using a binary thresholding, basically to binarize the image thresholding, and it's actually applying Watershed to separate the objects, so it understood my requirement there, and it's extracting the region props, like using the properties right there to find the mean. To me, upon first look, the code looks okay, but again, the goal is, does it work right out of the box? So let me copy the code, open my IDE right here. I like this because I can see the variables and all that. It doesn't matter what IDE you use. Okay, so let's, do we do anything? Okay, let's go ahead and run it and see what happens. Okay, as expected, no module name AICS, whatever that library is. And let's go ahead and see what the ChatGPT does actually. It says, okay, yeah, install the library. So it's giving me the right instructions, right, for this. So obviously, I don't blame the chat model for me not having that library, but I'm not happy with that specific library. Okay, let's switch to ChatGPT. This one's using CZI file like it is supposed to, because it knows that I'm working with a CZI image, so find the right directory. I like ChatGPT for code generation exactly for this purpose. But the approach here, you see, it's exactly the same, distance transform. It's doing Watershed, and it's measuring the region properties right there to get all the intensity and all kinds of other information, area, and so on. And it's actually doing the ratio. So I'm first curious about can it do a good job segmenting, and then the next step is obviously extracting intensities is easy. So ChatGPT.py, let's go ahead and run this. Okay, error. Index 2 out of bounds for, okay, I know why. You see on the top right there, you see how it says it's got like different dimension. That's the reason. So so what we need to do is, I mean, the model here, I mean, the chat engine there, it doesn't know at least it didn't know how many dimensions I have in my image. So it's actually saying, okay, take the third channel to be this, and it assigned it to DAPI, but then I have more than just 3 dimensions to my array shape. I got like 5 or so, right? So we need to fix that, and I don't blame again the chat thing. This is what I say: domain knowledge and a little bit of Python knowledge. Domain knowledge because you know what the CCI file is supposed to do and so on, and why you have 5, 6, 7 channels, and also the other, your coding knowledge, so you know you can go back and correct that in your code. Okay, moving on to the Copilot. Let's go to Copilot. Okay, and this also generated, and I hate Copilot for this reason. It says use OpenCV. There is no way you can use OpenCV to open scientific images, multidimensional scientific images like this. I'm going to go ahead and run, and obviously it's going to say something about none type object not subscribable. That basically means it didn't even read the image. My image is up there. As you can see, it's got nothing in the image, so it can't do anything. So I give up on Copilot already. Okay, so let's go to Meta AI. Oh, it's using CCI file, a good sign. I like it. And what I don't like is it gave code in different chunks. What should we do? Should we say give code in one chunk? I'll just copy this for now. Let's see how painful this is. I could have actually, no, don't worry. Let's just go back, copy the next one. I apologize if you're staring at the screen while I'm copying, pasting. I'll probably speed this thing up in the post-production. So let me be quiet for now. Okay, so after copying just the next lines, I just ran it to see if it throws any errors. No, it did not throw any error, but it's not doing something what it's supposed to do, because the channels, you see the array has a different shape, but here, yeah, we need to fix that. Okay, that was a bit painful. I should have just said, hey, give me the code in one go. Let's go to Gemini and see. It's also using CCI file. So other than Claude, everything else is, and of course, Copilot, they're suggesting CCI file. And here, it looked at a different dimension array. You see how it's getting there. It's showing me one less, shape, one less dimension there. But I like what I see here. So let's go ahead and paste our stuff there. Yeah, it's giving stuff in. Oh, okay. So this is a red flag right away. So there are a couple of things where we are not calling them, but then it included that in the code. It should be self-consistent. I don't know, again, why these type of silly mistakes still happen, but okay, so we know that. Okay, now let's go back to Claude. And I forgot what error we got. Okay, it says no module named AICS, Pi, lib, and CZI. So that is something we need to install. So let's come to ChatGPT. CZI file is there. So I'm not going to worry about the other AICS library. But here you see how the image, here, CZI file, how the image data right there, the array shape is 1, 1, 1, and then X, Y, and Z, right? Oh, no, 1, 1, X, Y, Z, and, Z, X, Y, and whatever the other dimension is. But then here, when it's looking for specific channels, it's actually extracting the last one. So this is not what we are, what we need to do, right? I mean, this is not what we want. Here, we need to tell the chat engine probably what, how to handle this shape. Maybe we need to provide that, hey, when you read this CZI file, this is going to be the shape. I think that's what we need to provide it. So yeah, let's look at, let's go ahead and do that actually. Okay, so let's go ahead and, so I was typing on the other screen, so let's copy and paste. Since the image is a CZI file, use CZI library is something I'm telling Claude. And note that the array dimensions is, whatever these dimensions are. So now it can actually modify the code. I can remove the first line for ChatGPT. It already got CZI file, but I want to give it information on the shape of my image array. Just forget Copilot. It's hopeless. let's go to Meta AI, and let's basically CZI file. Yeah, it's reading CZI file, so I'm going to use that and note that the array. Uh, okay, but let's say please give the entire code in a single, because I don't have patience to copy from multiple windows, making it easy for me to copy and paste. Okay, so let it do its stuff, and let's do the same. It's also here Gemini using CZI file, so let's go ahead and give it a shape. So yeah, it's using CZI, so we don't need the first line. Yeah, I think that's good. Now let's go back to Claude and see if it did any, yeah, CZI file. Awesome. Let's go copy the code without even reading, and we don't need to keep the first one. Oh, let's ChatGPT. Let's go to Claude. Okay, we don't need to keep this. Paste. You see the array shape right there. Okay, first of all, let me clear the variables from before. And now the array, I mean, when I run it, it gave me an array that says has one array. We'll come back. Again, it's not like it worked out of the box, but let's go to ChatGPT and copy this code and then see if it works right out of the box. Again, I'm doing a lot of edits here. Again, we are testing multiple chat engines, so it may look a bit confusing. Let's run it. Okay, so what does it say? Peak local max got an unexpected keyword, argument indices. Okay, now okay, Copilot, we gave up on it. Meta AI, it gave us something. Does anything work out of the box? Yeah, shapes, array shapes, everything perfect, because we gave it the information that it needs to know. Okay, so let's go ahead and, yeah, there you go. Paste it, and now let's go ahead and run. Okay, so SK image morphology doesn't have watershed, so error. Again, it didn't work out of the box. Okay, let's, is this the latest one? What did it say? Oh, it just gave me a new function for load CZI image and not the entire code. I should have asked it for the entire code. Should we just do that, or should we ask it for the entire code? Because there are a couple of other errors. But let's just replace this load CZI image part and run it. Okay, so it's not defined, right? So peak local max is not defined is something we need to fix. And I'm going to copy that error, paste it here, and let's see if it gives me updated code. Okay, so add that line. So we just need to add that at the top and hope that everything works. Okay, we know that we have another line that needs to be fixed, but that's okay. Let's go ahead and run. And now it says peak local max got an unexpected argument indices. So now it's not given that it's not there, but we need to take care of this indices. Obviously, it's using the latest library, but then the old library used indices. So now we don't need to use that. So let me copy that line and update that line here. Let's scroll down, local maxima. Okay, so this one, and let's run it again. Okay, now NDI is not defined. We know this. It's the next line. We just need to import that library. I don't know why it forgot to do that to begin with, but let's give that. And okay, solution, where is that line? NDI scipy.nd image. Okay, so scipy, from scipy import NDI image. What shall we do? Should we just copy? Did we call NDI image up there? Oh yeah, so it's as simple as changing that. Okay, now we got another error. Operands could not be broadcast, so there is some issue with the shape over there, and let's see if it can fix this issue. I hate when we go into this rabbit hole of asking questions and answers and modifying the code, and you can waste all day. You may as well write code from scratch if you know how to code. Okay, so it gave me a lot of English that I need to read through. I don't want to waste your time, but what did it say at the end? Okay, this is when I kind of give up. I'm like, I don't want to work with this anymore. Let's go to Meta. What happened with our Meta AI? The last we checked, it says this error. Okay, there is no watershed from SK image morphology. So let's come back here, type that, and see what happens. Okay, the watershed function has been removed from this algorithm. So here is the corrected code. Okay, I'm glad it gave me the entire code, which makes it easy. Copy, and let's paste it here, run, and ooh, no errors. But it did not segment what it needs to segment. Looks like it segmented the background or something, not the nuclei. And it reported intensities, and it did something. Okay, I think I have like 110 nuclei or 114-ish, but this thing is giving me 39,000. So obviously it's segmenting the background, thresholding the background and all that. Okay, so let's switch to ChatGPT, and okay, an error. Let's go to ChatGPT and provide this error. And what does it say? Due to the outdated keyword, peak local. Obviously, yeah, we know this. We saw this in other chat. I think it was in Gemini or somewhere. So let it write its stuff. And we'll copy and run this code and hope that it works. Okay. Okay, let's copy the code and paste it here and run it. Keeping fingers crossed. Could not broadcast. I hate when we get into this, like I mentioned. So both Gemini and ChatGPT seem to be making very similar errors. And let's see how good ChatGPT is at debugging and then correcting it. Okay, we got the code. Let's copy the code and let's go ahead and paste it here. Okay, I give up. Let's go to Claude. And I don't seem to have a lot of patience with this because I can, okay, let's see. Okay, this is fine. Let's go ahead and paste it. And let's see what it gives us. Okay, I'm glad it's giving us the entire code, so it's much faster at printing stuff. I don't know if the results are going to be good, but we already got the code. Let's go ahead and paste it here. Okay, this is let's just run it. Okay, peak local max. Let's go ahead and try this, and I hope one of these works actually. Oh, it's giving me the full code again. Oh, no. Okay, just this part. So we can go ahead and correct that. What is it? Okay, skimage.feature. Okay, so that's simple enough, I hope. Let's see. Feature. And where is it calling it? Segmentation.peak local max. And we need to change this to feature. I think that's it. Oh, hey, another error. It's got unexpected argument. We know this. We saw this before in other chats again. So this one I'm very hopeful of, but let's see if the code runs. Okay, so what do we need to do? Just copy this line, or should we copy the block? It seems like I'm wasting your time, but let me think. I changed my mind. I'll copy the block. Why make any mistakes? Right there. Okay, paste it. Okay, fine. Let's run it. Okay. Oh, we are not printing it on the screen. We are actually saving it as PNG, the segmented image, and the results as CSV. Oh, I love it. I love it. It's doing what it is supposed to do. It's segmenting. And we can, that's it. I mean, we can play with the settings for Watershed, to separate these objects, but this actually segmented. Great. And we should have a CSV, right? With all the, I'm hoping to see about 114 to 120 objects. Let's see how many nuclei did it detect. Let's go down. Definitely not hundreds of thousands, but a few more, like what, 355. That's because of over segmentation of nuclei. So let's go ahead and say, okay, the code works great. The nuclei are being over segmented. What can I do to adjust the sensitivity of nuclei separation? Yeah, I think that's good. I mean, it could be better. Let's correct any spelling mistakes. Okay, I think that's good. And what did it say? Okay. It says, okay, go ahead and adjust the sigma in the Gaussian smoothing, because obviously if the objects are smooth, you get better separation, right? I mean, uniformity, let me put it that way, when you're thresholding it. So changing the sigma is something. So let's change it to 5 and let's run it. And let's look at the image. It's done. Let's look at the segmented image. In fact, let's change these to also 9 and 9, the footprint right there for peak local maxima. Okay, so it's done. Let's see if we can open the saved image. And I'm hoping for fewer nuclei, right? Where is my image? You don't see my other screen, but let's find it. There you go. Okay. Oh, isn't that better? Now you have better separation between maybe some. Yeah, that's a much better separation. I think we'll probably get less than 200 nuclei now. Again, this is, oh, that's pretty good, 135. I know I have about 115-ish depending on who segments it manually. So I'm super impressed with Claude. It actually gave me what I wanted, right? So none of the other ones actually gave me anything. ChatGPT seems to be heading in the right direction. Yeah. So now what the key problem here is segmentation. If you do threshold-based segmentation, then you have to adjust the sensitivity for thresholding, sensitivity for, I mean, the smoothing for Gaussian smoothing before you threshold them, and then also the watershed sensitivity and all that. So that's a manual process. This is why deep learning can be very useful, but deep learning, I don't want to train my own models. So luckily, there is something called Stardist for nuclei segmentation. I'm pretty sure for other objects, you'll find off-the-shelf models that usually work very well. I know Stardist works very well. So instead of the threshold segmentation, can we tell chat engines that, hey, I know a model that already works very well for segmentation, so go ahead and use that. So the more information you give the chat engine, the better it is in terms of the quality of code it's going to give you. So let's do this one more experiment and end the video. I know it's a long video, but I hope you are enjoying this journey, the learning journey here. So what we're going to do here is everything exactly the same. Your goal is to segment individual nuclei. And note that the goal involves segmenting individual nucleus, not just the nuclei region via simple thresholding. Therefore, I recommend using Stardist library and working with 2D versatile flow. That's the pre-trained model. Everything else is the same. So let's do the same for ChatGPT. Let's run it. Let's do the same for Meta AI. Okay. And the other one I gave up, by the way. And Gemini, I'm still working on it, so let's go ahead and use it. Okay, so what did we get from Claude? Let's go back. Okay, it's doing a decent job, so let's copy it. But before that, let's see if it's using Stardist. Yeah, Stardist.model, Stardist 2D. I love it. 2D versatile. It's doing everything it's supposed to do. So let's see if it works right out of the box. Copy paste. So I have a new window here. Okay. Oh, so it is using the right, it's doing the right thing. It's predicting. I'll be shocked if it works right out of the box. For Stardist loading network, okay. So it's the first time it's actually using Stardist. So, oh, it says forgot to normalize, question mark. This is a prompt out of Stardist because you need to normalize the images. So the code did not do that. So our results are going to be bad. Let's go ahead and look at the PNG. Yeah, they're bad right there. I bet it has to do with normalize. We'll get to that in a second. But let's see what others did. You see, the normalize thing is something we need to because it knows that from the non-float input. So let's go ahead and copy that and paste it here before we move on to the next chat. And it says, yeah, so where is it? Yeah, normalized. So it did include this normalized step right there. And let's copy and paste it here. Again, I'll be shocked if it works. If that's all it takes to actually get, because the first time we didn't get error, we got a warning, obviously bad results. Now it doesn't come up with that warning message of forgot to normalize. And I am hoping it works fine. Okay, let's open the image. Oh my God, look how much better this segmentation is. Look at it. This is the advantage of the power of open source pre-trained models. So how many nuclei do we have? 107. Yeah, I think 107, that's pretty much it, right around 110. Nuclei 107 is probably the exact number. Let's now do ChatGPT. Super happy with Claude because it only took one extra warning to take care of it. Did it give a full code or no? Oh, okay, it did. It's just a code explanation down here. Okay, so let's copy ChatGPT. And I think it actually normalized. I see the normalized down there. So it actually already normalized it. So hopefully it works right out of the box. Okay, there you go, normalize. I love it. And let's run it. Okay, so similar screen and no warning about normalize and no errors. I have my fingers crossed you don't see them, but okay. So, oh, that's amazing. You see how the segmentation is amazing. Do we get 107? Because we are using exactly the same Stardist model to segmentation for segmentation. So our results should be reproducible. So if we look at the CSV, where is it? What is it called? Nucleus intensity and ratios.csv. And let's scroll down. We have exactly 107. Reproducibility. Talk about reproducibility. No matter where you use the same image, you get the same result when you use deep learning. With Watershed, we were getting whatever we want, based on different parameters. Moving on to Meta. Okay, this time I'm not doing the individual copy. So can you please give me all code in a single window, making it easy for me to copy and paste. Okay. Well, let's wait for that. Let's move on to Gemini. And okay, so region props, CGI files, Stardist, models. Did it not also do? Yeah, I don't see normalize here. Okay, but it's using the right model. Oh God, it says path to your model weights. Create a model. This is not how you use Stardist. Sorry, I'm not doing Gemini. That's not, I don't know. I mean, it's not workable for me. So I'm not doing that. Sorry. Let's move on to Meta AI. I was appreciating Gemini for a second. Okay, let's go to Meta AI, copy. Okay, hopefully it also works out of the box. No normalize here. And we got similar results as before. So let's go ahead and tell this that, hey, fix or address this, normalize. So it worked, no errors, right? Great. Okay, so what did it do? Okay, let's copy this part. Okay, and let's add, let's remove that. And this is the same line, so let's delete that. And there is the normalize. It's a traditional way of normalizing it. It's okay, it doesn't matter. As long as you normalize. Anyway, it should be good. Everything else is good. model.stardist to be pre-trained. Okay. No, we don't need that. We have it down here. So let's delete these lines and keep the ones above. Or you can ask the chat engine to give you the full code. Okay, 107 nuclei right there. We know we got something done, something good here. So let's go open the results, and we should have 107. You can also dig a bit deeper into are the intensities correct or and so on, but let us actually open. This is I forgot which one is from what. I'll actually put everything together. I'll pause the video after this. I'll put everything together, and let's go ahead and look at the results. So just give me a second. Let me pause the video and let me put labels on. Hey, this is this is that, because I totally forgot which one came from what. But let me continue this in a second. Okay, here you go. It took a few minutes for me to kind of put these things next to each other and add a title, but hopefully you didn't wait. So here, let's look at Claude, right? I mean, I sorted them based on the red to green channel ratio. And the first 4 or 5 objects, IDs like 89, 40, 106, 29, 80. If you look at ChatGPT and Meta AI, the first few objects are the same. But again, it depends on how we counted these and assigned the labels. So don't look at the labels as much. We are probably referring to the same nuclei in each of these images. But if you look at the red intensity, green intensities, and the ratio, they're statistically exactly the same, right? Statistically identical. In fact, if you look at Claude and Meta AI, I'm a bit surprised how they match all the way to like the 4th, 5th decimal for most of these objects. So you're getting statistically exactly the same result no matter what code you ended up using, whether it is Claude, ChatGPT, or Meta AI. So again, the reproducible aspect is coming from the fact that we are using a deep learning trained model like Stardist. So that also highlights the importance of deep learning techniques when you're looking for reproducibility. Again, the lesson that we learned here again is I would definitely use ChatGPT for now for coding to generate any code because even with the first approach, it actually did a good job. In the second approach, once we tell it that hey, you haven't. It actually did normalize it. The code actually worked almost out of the box in this case, and Claude is my second option. I like Claude for text generation. I like the results I get from there. It doesn't look like it's got a lot of marketing hyperbole, when it's writing this. ChatGPT tends to exaggerate the text and make it sound very artificial. So if you're looking for, text generation for whatever purpose, marketing or your personal emails, I definitely recommend Claude. And Meta AI, it's there. It's not mind blowing. I mean, the new thing came out, but I don't see a strong reason why I should change my habit of using ChatGPT or Claude for now. Okay, this ended up being a very long video, and if you're still here, I really appreciate your patience. And again, do not forget to hit the subscribe button if you haven't already done so, and let's meet again in another video. Thank you, guys.